us today in this microservice webinar. My name is Francisco Ponce, and I will be talking about security SML in the context of microservices. And this specific talk is about uh, if should microservice security SML stay or be refactored. We are trying to enable, in this context, a trade-off analysis process. Okay, so just for a little of context, many IT companies are delivering their business through microservice-based applications, which are basically or essentially service-oriented applications adhering to an extended set of design principles, which include independent deployability, horizontal scalability, microservice failure isolation, microservice decentralization, and so on. Along with the benefits of this type of architecture, of this type of applications, microservices-based applications also bring new security challenges, including the so-called security smells. If a security smell affects a microservice-based application, this can suffer from security leaks, and this specific security smell need to be refactored to mitigate the effects of this security smell on the applications. So what is a security smell? For us in this research work, a security smell can be observed in a microservice-based application being a possible symptom of a bad decision, through often unintentional, while designing or developing microservice-based applications, which may obviously impact on the security of the whole application. The effects of security smells can be mitigated by refactoring the application or the service terrain, while at the same time not changing the functionalities offered to external clients. When we talk about refactorings, we know that they require some effort from the application developments, but in generally, it's known that this can help mitigate the effects of smells and improve the overall system quality. So in this context, and in this research project that I'm talking about, we want to mainly answer two research questions. The first one being, what are the smells indicating possible security violations in microservice-based applications? And how to refactor microservice-based application to mitigate the effects of security smells. So to resolve or to answer these research questions, we try to organize the scattered knowledge on security in microservices, and we did as you have there in the title of the slides, a multivocal literature review. So why a multivocal literature review? Because we wanted to capture the state of the art and practice in securing microservice-based applications. So we conducted a multivocal review of existing white and gray literature, and in resume, we systematically analyzed 58 primary studies. We have applied some including and excluding criteria to a certain body of knowledge. And we have selected 48 primary studies. And with that information, we have carried out an analysis process and extract some security smell refactoring from this body of knowledge. Okay, so we have a little of context, right? We have microservice-based applications. We know that they bring some benefits to the business industry, but they also bring new security challenges. Among them appears the security smells that we know now, right? That are a symptom of a bad decision, often unintentional, that is hurting the system, the security of the system of the application in some way. Let's see an example then of what is a security smell of in this context, and I will present in this case the insufficient access control security smell. So this particular smells occurs whenever a microservice-based application does not enact access control in one or more of its microservices. Uh, why this can in some way hurt the confidentiality of the application is because if this smell is present in the microservice-based application, the microservice itself, being then part of the application, right, can be exposed to the confused deputy problem. What does that mean? This means that, for example, an attacker can trick a service and get data that they should not be able to get because we lack certain access controls in some part of the applications. In this context, obviously, the microservice-based applications are not suitable for traditional identity controls models, since clients' details and permissions need to be verified as and when a request is sent. And this type of application need a way to automatically decide whether to allow or reject a call between services. This smell, in particularly with the information that we have recovered from the primary studies, we know that affects the confidentiality of the microservice-based application. So let's see also another example, the centralized authorization security smells. This smell This smell occurs when the microservice-based application only handles authorization in one component, typically at the edge of the application, and while does not enact any fine-grained authorization control at the microservice levels. So uh, so we have, for example, the API gateway, right? That is the typical component that we have in a microservice-based application to filter the requests that are entering the application. So we are used, for example, managing authorization at that component and not at the microservice level. Here, there is like two approach. In this context, we can found the trust the network approach and the zero trust the network approach. If you want, we can talk about them after the presentation. But in general, here are two approaches that you can follow. And if you follow, for example, the trust the network approach, this particular smell can appear in the microservice-based application. So why is this a problem? Because when authorization is managed only at the edge of the application, microservices are exposed also to the confused deputy problem. This means that they trust the gateway, right? We were talking about that, based on its mere identity. That means that since the request has been authorized and authenticated by the gateway, we trust that request in the whole application. So this can expose the microservices to the misuse of them if they are exposed or compromised or captured, right, for an attacker. We know with the information that we have recovered that this particular smell affects the authenticity of the application. So here we have two examples, right, of security smells in the context of microservice-based application. We have recovered the information about 10 security smells and 10 ways to refactor the microservice-based application to mitigate the effects of these smells. And with this information, we have obtained a taxonomy of security smells that includes these 10 smells, and we have organized them around the security properties defined in the ISO 2010 standard for software quality. In particular, we have recovered information that these smells can impact the confidentiality of the application, the integrity of the application, and the authenticity of the application. These three security properties are part of the security category of the ISO standard. Here we have the 10 security smells. We have already discussed in some detail, right? The insufficient access control smells and the centralized authorization smells. So you have ways to mitigate the effect of this smell. You can access all this information in this reference here if you are interested in know more about the security smell and how to refactor them. And with this information, we found that it's not easy. It's not trivial to decide if we should always apply, for example, a certain refactoring. So this is one of the problems that we have found in this investigation, because whether to keep a security smell or apply a refactoring is a decision that deserves careful analysis. Why? Because the smell and the refactoring can impact on several aspects of the application, including other quality attributes besides security, because security is not the only quality attribute that is part of the application. Security is security share, right? The application with other important quality attributes, and also some microservice key design principles that we were mentioning in the beginning, right? Isolation of failures, decentralization, scalability, and so on. And we have found that these smells, for example, the insufficient access control, can also impact on other quality attributes besides security. And for example, centralized authorization also can impact on other quality attributes besides security. So it's not trivial to decide in each case whether it's worth to apply a certain refactorings if you don't have all the information to make the, the right decision at least at certain time. Let's see an example of this. So we have the centralized authorization security, right, that we have discussed before, being this one, right, that a single component is used to centrally authorize external requests sent to the microservice-based application. In this particular case, we know that the smell affects the authenticity of the application, being the authenticity a property of the security of the application. But we also know that this smell hurts this decentralization design principle, since it happens when microservice since when it happens, microservices depend on a central component to manage authorization. So this contrasts with the decentralization design principle. And we also know that this particular smell can hurt the time behavior of the application, since the central authorization component can become a bottleneck if the application considerably grows in the number of microservices. Since it's a central component, it can become a bottleneck if the number of services grows with the time. So here we have some properties that are different from security that are being affected for this microservice security smell. And also, we know with the information that we have recovered that if we resolve the smell, resolve uh, means that we apply the refactoring to mitigate the effect of the smell. We are not completely removing the smell, but we are considerably mitigating the effects of this smell. So why not always apply this refactoring? Because this refactoring can complicate the application testability, since the fine-grained authorization control that the refactoring of this application propose must be tested independently, hence scaling with the number of microservices that compose the whole application. And we also know that with the information that we have recovered, that this refactoring can impact or at least hurt the resource utilization of the application, since this approach requires more information to be transmitted for each request. Because, for example, if we are using a token-based approach, the token will be always uh, transmit with each request. Therefore, obviously, they will cause a higher consumption of network resource. With this in mind, since we are trying to process, right, to analyze whether it's worth to apply a refactoring to mitigate the effects of ASML. With this in mind, we want to provide a visual tool and a holistic panorama of the positive and negative impacts of each security smell and refactoring on the quality attributes and microservice key designs principles. So in resume, we want to enable the reasoning on whether it's worth to apply a refactoring if I'll, or if I will stay with the smell in my system, because some other properties that are different from security are important for my business, for my current context, or another situation that can appear. So to allow us to enable the reasoning, right, of a trade-off analysis, considering all the impacts that can have these two decisions, right? Keep the smell on the application or apply a refactoring. We are using a representation that allows the model of non-functional requirement, specifying the interdependencies among them and determining how to operationalize them. This technique is called SIGs, a Softgoal Interdependency Graphs, that is composed for four main components. A softgoals, that is a non-functional requirement, and operationalizing softgoals, that is a way to operationalize the the non-functional requirement is a design decision. The impacts, this means the interdependencies among the soft goal and the operationalizing soft goals, and claims. Claims are the rationale behind the interdependencies among these components that I am currently describing. So we propose the use of SIGs to support the analysis of trade-off related to keeping a security smell in a microservice-based application, or apply a refactoring that is known that can mitigate the effects of this particular security smell. In this context, we are exploiting this graphical representation to model quality attributes and microservice key design principles at Softgoals, as you have here in the screen. We are exploiting SIGs also to consider a way of operationalize these quality attribute and microservice design principles through the security smells or the refactoring. And we are considering the impacts of these two design decisions on the quality attribute and microservice design principles through the notation that is provided for this graphical representation. Let's see an example. So we have talked about the taxonomy of microservice security smells. Here we are extracting a little part of the taxonomy. With in this example, we will focus in the publicly accessible microservice smell and the multiple user authentication smell. These both security smell can be mitigated by adding an API gateway to your microservice-based application. So we know that these two smells hurt the security of the application, and specifically publicly accessible microservices affects confidentiality, and multiple user authentication hurts the authenticity of the application. So we can model this in using this graphical representation in this way. We have the security of the application as a soft goal. We are also considering the properties that are part of the of security as a way to specify, right, these quality attributes, being them the ones that are part of our taxonomy, at least for this current work, confidentiality, integrity, and authenticity. And we have the two design decisions, right? For example, keep some publicly accessible microservices. And we know that for this relation that we have here, that this hurts the confidentiality of the application. And if we apply, for example, this refactoring, that means add an API gateway, we improve in some way the confidentiality of the application and also the authenticity of the application, because we are mitigate the effect of these two smell that we have here. So this is a way to provide a visual representation of the impact that these two design decisions have on the quality attributes of the microservice-based application. Okay, with this context, we can now go to a illustrative example. For this example, we will consider the centralized authorization security smell. So we have the security as a quality attribute of the microservice application because the security smells lives in this context, right? We have then the keep centralized authorization design decision because we will we want to reason if we want to keep this smell in the system. And we have also the use decentralized authorization design decision because we know for the information recovered that this is their factories that allow the mitigation of the effect that this smell can have on the system. So keep centralized authorization has a negative impact on the authenticity of the application, and use decentralized authorization has a positive impact on the authenticity of the application. Now we can include the microservice design principles as another dimension that we want to analyze, right? We want to consider in this analysis process. With the information that we have recovered also from previous work and the information that at least our research team has, we know that the use decentralized authorization improves the decentralization design principles because obviously this refactoring suggests decoupling the central authorization component that that each microservice has its own fine-grained controls. And we also know that the keep centralized authorization goes contrast with the decentralization design principles because we have used a centralized component, right, to authorize the requests that enter the application. But here we have an impact that have a S plus, right? That is different from the ones that we have just discussed. In this context, we have not the complete information to infer if these design decisions improves or improves or certainly improves the interdependent deployability of microservice based applications. So we are supposing that this design decision has a positive impact on these design principles. So we can exploit this graphical representation to model certain impacts that we already know. And we also can infer or expect some impacts that these two design decisions have on the properties that we are considering in this analysis. So obviously this information needs to be validated. We will discuss this in a little more detail uh, when we advance in the presentation. So now we know also because we have discussed this before that the centralized authorization has here's the time behavior of the application because this can become a bottleneck if the number of services scales. So we can add the performance efficiency quality attributes and the properties that are part of the performance efficiency. And we can also model here the impacts. We have these impacts model as expected impacts because we are not completely sure if this impact is meaningful, for example, or this impact is completely true, so to say. So uh, these two interdependency need to be also validated with more work to do. And also we can add another dimension that, for example, we are interest or maintainability is a critical property, for example, for our system because we are currently work a full capacity. So maintainability of the application is really important for us. We can also add this quality attribute to the analysis and model the impacts that these two design decisions can have on these on the maintainability properties. Here we have that keep centralized authorization improves in some way the stability of the application because obviously the authorization controls need to be uh, tested and verified only in one component, and they use decentralized authorization since it's suggests decoupling the central authorization component and that each microservice has its own fine-grained access controls, hard in some way the stability because now you need to do more work, right, to test each of these fine-grained access controls that you will have in your system. Let me just take some air. Okay, so we also expect that this refactoring, they use decentralized authorization, has a positive impact on the analyzability of the application, since each fine-grained authorization control can be modified independently, minimizing the impact that it has on the rest of the microservice-based application. And we also expect a positive impact of the use decentralized authorization design decision on modularity, because obviously we are decoupling now a central component in uh, fine-grained access controls, right, that are part of each of the microservices that are part of the application. So in resume, we can have a four-dimensional analysis to uh, to present, in this case, the impact that keeping an smell on the system and applying a refactoring can have on the different application properties that we are interested on analyze, so to say. Okay, so just to conclude the presentation, now that you have an idea, right, of what we want to do and what we are currently working on, we are using Softgoal Interdependency Graphs to support a trade-off analysis process, presenting a four-dimensional analysis, as we already saw in the illustrative example. And each of these six aims to provide a holistic view of the positive and negative impacts of security smells and its possible refactoring on software quality attributes and also microservice key designs principles. And so basically, we want to show the impacts that these security smells and refactorings have on other properties besides the security of the application. In our current and future work, we basically are extending our SIG-based methodology to other security smells, to the ones that are part of the taxonomy that I have also present in this talk. And we want to validate, obviously, the methodology with practitioners through uh, interviews, for example, surveys, and so on. We want to basically validate the S that are part of the visual representation, because we want to have the complete knowledge, so to say, to provide the best visual representation possible. And we also are currently developing visual tools that will provide the information of the security smells and the refactoring, all the information that we have recovered. And we'll also incorporate the SIGs, adding, in this case, the claims that I have not talked here in the current talk, being them basically the rationale behind of the impact that we are modeling, that we are currently modeling in the SIGs. So that's the end of my presentation. And also, before the question, since we want to validate the information that we present on the SIGs, if you want to contribute with your knowledge, for example, you have experience, or you have been part of a project that one of these situations occurs and you have resolved this situation, you can provide that information, if you want, to our research team in order to provide the best information possible. That's the end of my talk, and thanks a lot. Thanks a lot for the attention, and I think that's all.
Thank you, Francisco, for the nice talk. I was wondering whether there are questions from the audience.
Yeah, I have one or two questions maybe. First of all, Francisco, thank you for the presentation. I found it quite interesting, especially when you identified the security smells and proposed some solution like integrating the API gateway, for example. I found there are two papers about your talk, right? The one with the literature review and the one with the towards the SIG graphs, right? Something like that.
Yeah.
Is there this mapping for the smells and the proposed solution in this publication? I just scanned them briefly because I found this mapping quite interesting. Okay, then it's in the literature review, right? Because I haven't got that from the page I found it on.
So we have published the process of extract the smells in JSS, the taxonomy and so on, and all the information that is part of each of the smell and refactorings. And we also have published this idea, right? The six representation in X as a
yeah, I
energy.
found it there.
Yeah, exactly.
Okay, so how do you are you planning on doing something on identifying the smells automatically from the source code, for example, something in that way?
Yeah, it's one of the things that we can do. For example, try to, in this case, to improve more this current work, right? For example, automatically detect a security smells and on a system, on propose, for example, the solution, on also the visual representation of the impact that these two scenarios can have. Right, that is one of the areas that we can exploit in this work, but we are currently just trying to have some ideas of how to do it, because it's not an easy process where, for example, identify one of these smells in a certain project, because depend in a lot of scenarios.
Yeah, because I asked because I did some work on identifying more general smells or anti-pattern in microservice architecture. For example, that they're using hard-coded endpoints, for example, or no application gateway. And I did this model-driven based on Florian's lemma approach. And I think it's only some kind of bachelor CSI supervised where this implemented. But I think this approach it worked quite nice. So you can then the models are analyzed, which are maybe created manually or reconstructed from the source code, and we have these models, and they are technology independent, so we can analyze them maybe a little bit easier than we have to do it for every programming language separately. Yeah, so maybe we could do something together in future, but I still need some time to get to this point to get the models automatically reconstructed. So maybe we have a talk in half a year or something like that, because it maybe would be a good point to work together when you working on the to identify these security anti-patterns and do all the trade-off between this are the trade-offs and these are the benefits of refactoring the source code. It may be interesting in future.
Yeah, sounds really good. Actually, it's a really nice suggestion. So perhaps we can do something together in the future. Sounds like a really good idea.
Yeah, maybe when I have a working approach for identifying the general patterns, maybe I will write you an email and then we can have a chat about how to integrate the security-based anti-pattern, for example.
Yeah, sounds really good. Thanks a lot for.
Yeah, only when you're interested. So.
Thank you. So, any other question from the audience? So it seems not. And this is one of those cases in which it would be not so meaningful that the chair is asking questions, because we are cooperating on this. So, I mean, I won't make.
So maybe we can get the Google Forms link in a more text-like link form, so we can click on it not have to type it from slides. So
no.
Yes. Yes.
Or maybe you can
will
share the slides afterwards, maybe, so we all get them.
Exactly. We will share the recording of the video, and we will put the link together with that. I mean, you will get information. We get messages from EU, the communication group, in a while.
Of course.
Okay, so I would thank everybody for attending this webinar, and I invite you to attend the following one as well. And in case you want to propose any topic for a webinar, please, as usual, feel free to contact me. So thanks, and see you soon.
See you.
Thanks a lot for everyone to be here.
See you.
Thank you very much. Bye.
See you.